This is a forces and torques question, or both 9 and 10 are forces and torques questions. Right, in the first one we've got a man, Pete, who's standing in the middle of this plank, right in the middle, and which is the best estimate for the upwards force each support exerts on this plank. So what we've got is if we were to draw the forces, what we know in the middle, so we always take the middle as centre of mass, as the mass acting from the plank. Right in the middle, the plank has 120 kgs, which equals 1200 newtons. We've also got, standing right in the middle of the plank, we've got Pete, who's 80 kgs, and that's 800 newtons. So all together, if we were to put them together and as one big arrow, cross these out and just have one arrow, we'll make it blue. There's one arrow down of 800 and 1200 is 2000 newtons. This plank isn't accelerating anywhere. The total force on the plank equals 0. So there must be a force up here from this guy and a force from this guy, which cancel out with this 2000. The only way for that to happen is that this is 1000 newtons and this is 1000 newtons. So that's that answer there. Alright, Pam is now, she's a different mass. She's 60 kgs. And she's now standing here, not in the middle anymore, so it makes it a little bit harder. And they want us to know what's the force on support Q. There's two ways of doing this. The first way doesn't work, well, the first way works with this question because of the multiple choice answers they've given us, and you'll see why in a second. So there's a mass of 120, so right from the middle there's a force of 1200, and there's Pam's force of 600. So just like before, the total force on the plank must be 0 because it's not moving. There's a downwards force total of 1800. If Pam was standing in the middle, there'd be a 900 and a 900. But she's not standing in the middle, she's standing closer to, if this is your plank, she's standing closer to this side. So this side must have bigger, slightly bigger, and this side must have slightly smaller. So this could be 1000 and this could be 800. Regardless, it's going to be bigger than 900 and this one's going to be smaller. And the only answer where Q is bigger than 900 is D. So that's one way of doing it, a quick way of doing it, but that was only because there was only one answer bigger than 900. If there was two answers bigger than 900, we would have to do the working out, which is what I'm going to do now. So the second way of doing it, that was way 1. Way 2 is actually working out the torques. So the rule is the torques, the clockwise torques, cancel out with the anti-clockwise torques because this thing is not rotating. And torque is equal to force times distance. Because we want to work out at support Q, we choose our centre of rotation. We choose it to be the other one, P. So our centre of rotation is here. Centre of rotation. Right, what are the forces causing this plank to try and, well, what are the forces trying to pull this plank and rotate it clockwise, so in this direction, around that centre of rotation? Well, that force and that force, is two of them. So I'm going to put the torque as force times distance. I'm going to substitute it in here. We've got the force, the first one, and we've also got plus this one here. And what are the torques trying to rotate this guy that way around the centre of rotation? Well, it's the force going to be provided, or the torque provided, sorry, from support Q. It's trying to hold it up. Force Q times the distance. Now each of these distances is from the force to the centre of rotation. So the first one, force times distance, is this guy here, 1200 times, and the distance is from here to here is halfway of 4 is 2 meters, plus force of 600 times the distance from here to the centre of rotation is not 1 metre, it's 1 metres to this side. It must be, if the whole thing's 4, it must be 3 metres from here to here. And that equals the force from Q, which we don't know yet, times the distance from Q to the centre of rotation. From Q here to the centre of rotation is 4 metres. Let's just simplify that. 1200 times 2 is 2400, plus 600 times 3 is 1800. That equals 4 times the force of Q. Add those together, you get 4200 equals 4 times the force of Q. And divide both sides by 4, you get 1050 equals the force of Q, which is the answer we got.